Hello friends, my name is Malek and welcome to the next part of Terraform and Terragrunt tutorial. In last 4 videos, we started using Terraform to create a network component on AWS. Then change it to a module that can usable in multiple environments. Today, we will talk about Terragrunt and we'll see how it can help us and increase capabilities of Terraform. Let's start. At first, let's see how Terragrunt can increase capabilities of Terraform codes. This is official website of Terragrunt. As you see, in the middle of page, it is written DRY and maintainable Terraform code. Terragrunt is a theme wrapper that provides extra tools for keeping your configuration dry. Dry is abbreviation for do not repeat yourself. Let's back to our VS Code. If you remember from the last sessions, here, for example, in dev environment, in US East 1 region, we have created some codes here. If we look to main.tf, you see here, we use this block for backend configuration. If we look to another region, here also repeated here. If I go to production environment in US East 1, also you see here it is repeated here. So Terragrunt help us to avoid repeating such blocks. Just write this piece of code once and use it in all environments. This is DRY. Do not repeat yourself. Another example, if you see here, again, we use the module block to call our modules. There are some variables we have to use with module. Otherwise, module don't know your declaration. You see, in all environment, we use these variables. Here, Terragrunt also help us to optimize our code. Another example, if you see, and we talked it in last session, I told you in backend we cannot use variables. For that reason, in key parameters, we had to use static parameters. Here, Terragrunt also help us to use variable in backend block. In Google, if we search for Terragrunt blocks and in the result we click on the first one, you will see which block we have to use in Terragrunt configuration. Before going into Terragrunt blocks, let's go to Google and search for Terraform configuration language. As you see here, it is written by HashiCorp configuration language, or in abbreviation called HCL. Let's back to VS Code. Here you see there are some files that was generated automatically with the extension HCL. So here Terragrunt using the same format. So for using Terragrunt, we have to create a file called terragrunt.hcl. Let's create a file called terragrunt.hcl. Let's back to official website of Terragrunt in the blog section. The first block we can use, it's called Terraform. What is the Terraform block? The Terraform block is used to configure how Terragrunt will interact with Terraform. Normally, Terragrunt is like a thin wrap around the Terraform. So we need to know how Terragrunt can interact with Terraform. So with using this Terraform block in Terragrunt configuration, it helps us to communicate with Terraform code. Let's in first step create a Terraform block in Terragrunt configuration. Let's go into VS Code, and in the terragrunt.hcl file that we have created, just type Terraform and add open and close Oculad. As I told you, we need to communicate with Terraform code. So which parameters we need to add here? Let's back to Terragrunt documentation. The main one is source. So here Terragrunt say to Terraform, hey Terraform, from where I can find the module configuration. You see here where to find Terraform configuration files. This parameter supports the exact same syntax as the module source. As you remember how for the module we use the source. Here is the same. Let's back to configuration, type source. So source is located where? So for the source, the same as we used in the main, just copy this one. So for access to module, one step, going to US is one, two step, three step, and we arrive to environment folder, then going to the module and network. If your module not located in your local machine, for example, they are located in GitLab, GitHub, or Terraform registry, you can use another format. For example, if it is located in Terraform registry, you can use TFR and the path of your registry. At the moment, we are using like this because it is located in our computer. In main file, you see we have to pass this variable's value to module that can generate a proper config for our environment. How about here? Do we need to pass such variables? Let's have a look to terraform.tfvars. You see here we declared our variables here. So we can use this Terraform TFVars for that. How we can use it? Let's back to documentation, and in Terraform block going down, you will see extra argument. For using that, it is better going down to see some example. Let's copy this one back to VS Code in terragrunt.hcl here. Let's clear this one and change it to Terraform, the same as this one here. Let's save it. How about this one? At first, we can use every name here. Let's leave it as is. Custom vars is good. Okay, so this one commands what it can do for us. Let's back to documentation and see here commands. It's required a list of Terraform subcommands that the arguments will be passed to. What's the meaning of that? It means the declaration in this file will pass to module during running this command. For example, if I remove this one, it means if I run terragrunt apply, only the declaration value in terraform.tfvars will be transferred to module. If I run terragrunt plan, it doesn't work. Anything will pass to module. So it is better to have them here. So if I run terragrunt plan, terragrunt apply, terragrunt refresh, and so on that we have defined here, the values in terraform.tfvars will transfer to module. We will see it in action soon. So the Terraform block with the minimum configuration is ready. So let's back to documentation and see what another block we need to run our terragrunt code. But before going that, let's see main.tf. Here we have to define the backend. If we don't define backend, the terragrunt or Terraform don't know where have to save a state file. Let's back to documentation. After Terraform block, you see there is remote state. The remote state block is used to configure how Terragrunt will set up the remote state configuration of your Terraform code. So it is one of the mandatory blocks that we have used in Terragrunt block. How to use that? Just let's going down. Let's copy this one and back to VS Code in terragrunt.hcl. Here, paste it here. As you see here, the parameters are the same as we defined in main.tf. Let's copy this one from here, Control C, back to here, just to know what we want to use. Bucket, just copy this one. For the key, copy this one. Also, let's copy these two parameters. Let's save it with Control S, and we need to explain something here. Maybe at the moment something hit your mind. Hey Malik, you told us we don't need to repeat remote state in all environment and region, but you copy it here. So how Terragrunt wanted to get rid of that one? Okay, be patient and we will discuss about it. Okay, let's think what we can do to prevent repeating such block code. If you see in the left side, in the environment, we have dev and production environment. If I want to copy a remote state block in dev environment, US is one region and also for another region, US West one, it is repeating the code. Only thing here that have to be changed in each environment is the key. You see here it is for dev US is 1. For the West one, we have to change this one. In the production, also we have to change the key. We can copy this one and copy it in another file that can usable for all environment. Let's create a file in environment. Every name you can use it, but for the extension, we have to use .hcl. I'm using the command as a name .hcl and put the code here. Let's back here and check. Just delete this one to get rid of that here. At the moment in terragrunt.hcl, only we have Terraform block. Let's create the same for US West one in dev environment. Create a file called terragrunt.hcl and copy the content from this region to US West one. Okay, now these questions comes to mind. How we can connect command.hcl to terragrunt.hcl, from where terragrunt.hcl can find command.hcl. Here, another block called include comes to play. let's see what is include block. The include block is used to specify inheritance of Terragrunt configuration file. There is a description for include. With using include block in terragrunt.hcl, we can address another Terragrunt file. To see here, you can learn more about inheritance properties of Terragrunt in the filling in remote state setting with Terragrunt section. Keep your remote state configuration DRY, the same that we are doing. Let's click here. You see here there is one file as terragrunt.hcl here and some in the folders, one in backend, one in frontend, in MySQL and VPC, and from each file can access outside terragrunt.hcl. So let's copy this code and replace to our code in common.hcl and back to VS Code, common.hcl. Let's put it here. This code will generate a backend.tf for us. Where is the path of that? In the same directory that this file is running. So if this file exists, overwrite the content on it. So the bucket name, let's copy from here, replace here. For the key, leave it as is at the moment. Region US East 1, DynamoDB, let's copy DynamoDB table. Only for the key. For the key, you see here, it is using one of the Terragrunt function, path relative to include. Leave it as is, I will explain it. Let's back to terragrunt.hcl here. Under this code, you see include block. You can give it a name and also a path. Let's copy this one and back to VS Code and put it here. Include root path find in the parents folder. So this include block, look top folders from that located and find the file with .hcl. Inside the parentheses, if we don't define the name of Terragrunt file, it will go and try to find terragrunt.hcl, only the file with the name Terragrunt. But if we declare a name here, only will go to find that file. Here, as you see here, we defined common.hcl, so it is better to use the name here, common.hcl. So it will look up this file in the parent folder. So let's back to common.hcl. Here, function path relative to include. What's the meaning of that? When the include block in terragrunt.hcl find this file, this function calculate the path from here to that include block. For example, if the include is here, you see, where is the path of this one? Let me write here, and after that I will remove it. This terragrunt.hcl is located where? It is located in dev US East 1. Let's copy this one and remove and back to common. So here it will be dev /US East 1 / terraform.tf state. I think so far so good. So in next step, we are going to run our code and see what will happen. Let's run Terragrunt configuration in US East 1 and see what will happen. Before that, you have to install Terragrunt on your computer. If you are using Windows operating system, I made a video how to install Terragrunt on Windows operating system. I have pinned this tutorial about this video. If you are using another operating system like Linux or Mac operating system, it is easy by searching on internet and you can install it. At the moment, I have installed it on my computer. Just now I need to go in this folder, cd environment, dev us east1. Before run Terragrunt, we have to remove or rename the Terraform codes because we don't need them anymore. Let's delete this one, delete variables. Only we need terragrunt.hcl and terraform tfvars. Also let's remove the other files, we don't need them. Only we need these two files. Let's run by terragrunt init. Terragrunt init, like terraform init, will initialize your codes. Let's run it. Here you see a warning, no // font in the source, as also it is written in document. When we arrive to the module folder, we have to write // It's like cd folder name, so it is better to use // here. Let's run it again. Yes, this warning removed. Let's look to the file that was generated here. One of them is terragrunt-cache. Let's open this one, and from the first one you see backend.tf is generated here. Let's click on it. You see the key has been generated, dev folder /us is1 /terraform tf estate. This one generated from the common.hcl. So this one generated here. As you see here, this issue that we had with Terraform solved with Terragrunt. Also, only we have two files, Terragrunt and this one. Let's run Terragrunt plan. See what will happen. You see, select this one, US is one. See the CIDR block 10.10.00/16 like here. For the public one, use 10.10.1.0/24, and also for the private one, use this CIDR block. For apply, just we need Terragrunt apply, and it will apply configuration to AWS environment. Let's do the same for US West 1. So at first just check terragrunt.hcl. We need include one. Let's copy this one and transfer to US East 1, and also add // here, and also delete the extra files from here. Just we need these two files, cd US West 1, Terragrunt init, plan, and see what will happen. You see here, selected US West 1 from the Terraform TFVars, also CIDR block for VPC, selected from here, and the same story for the private and public one. Let's check auto-generated file here in Terragrunt cache. In module, let's see network backend. You see here, dev US West 1 Terraform TFS. If we run Terragrunt apply, it will provision it in US West 1. You can do it by yourself for production. Just create two files, terragrunt.hcl and terraform.tfvars, and you will see the result. Let's finish this session here, and in next video I will explain a little more about Terragrunt, and I will update the codes for best practice. See you.